watch this YouTube video that will give you more insights on how you calculate the support that I've alluded to, confidence and lift. I just ran through on that aspect. So this URL will assist you. It's a very short video. It's about 12 minutes. And also this lecture, this is the resource link for the Jupyter notebook that we are going to be using. I want you to go through should you fail to understand the concept as the lecture progresses. And also I'm going to share with you a PowerPoint presentation with more notes on association rule. So in the interest of time, let me just paste this to the public chat so that you may have access to the resources that I've alluded. All right. So the data set that we are going to interrogate is a data set from the University of California, and it contains online retail sales, and it for gifts from different countries in the Europe and Asia. And it so data set is products that were being sold. They are gifts, and so we may not be accustomed to some of the gifts that that are contained in the data set. So I'm going to share with you the data set on our WhatsApp platform. Let me do it right away. Web mining. All right, there we go. All right, let me paste the document. There we go. Right, so I've just shared with you the data set. In the interest of time, you can just watch as I present to you, or should you be in a position to quickly copy, don't hesitate to tell me if you are experiencing any errors. Can you confirm that you have received the data set? While least I'm importing, it's quite a big data set. It will take 2 minutes to import. Allow me to pause for a second the recording. Okay, it's still importing. Marionere dataset. Can you confirm receipt of the dataset?
Affirmative.
So these are the challenges that comes with the computer with the low processing power. Tambotaura nyaya yekuendera large datasets. Normal machines they are pedza read the dataset. Let's give it a few more seconds. I'm sure it should be able to read. Can you confirm that you are in receipt of the dataset?
Yes, we've received it, sir.
All right, let me also share my PowerPoint presentation for association rule whilst I'm reading my dataset. All right, with mining. There we go. This desktop. association rule, some notes. All right. I think we're good to go. Let me print the head. It's displayed there. It is displayed the first 5 records of the data set. So the next course of action, we want to process the data into a matrix. So this is the data. We've got the invoice number, stock code, description. This is our product that was sold, the quantity, the date of the transaction, unit price, and so forth, and the country. So we are going to process the data. So our first point of call, we want to convert our invoice number into a string data type, and the description, which is the product. Okay. All right. So this is the code that comes with it. Then the next point of call is to drop all now values. We don't want to work with now values. So I'm sure you're accustomed to this code. Drop NA. This is our data frame. And we are now dropping all now values. Still executing. Right. Then the next course of action, we want to filter out data from the country German to data from. As you can see, it's taking time because our data set is quite big. So in the interest of making it a bit smaller, we want to create a new data frame with the name data underscore DE, and filter out using the country German, so that data DE will contain data from German only. All right. I'm sure it should be completing the execution. Is the asterisk is still showing? Let's give it more time. So this is part of data cleaning exercise, where we are trying to make sure our data is clean before we subject it to the output. Right. I'm sure if we filter out, we will be good to go. Still processing. Oh, yeah. Can you confirm that you have received the materials? And also, can you confirm that you have received the link for this particular presentation? I got this link online, so I think it will be in the best interest of everyone to visit that link, though it does not have comments. The URL doesn't have much comments. All right. So here I've just executed the code to filter out data from Germany, and we've just stored it in a new data frame, data underscore DE. All right. Now we are now doing what we call feature selection to say that for this particular exercise, the data set that we have has got so many columns, but for us to achieve the business of the day, we only need the invoice number, the description, and the quantity. The description being the product that was purchased. Okay. So to do that, this is the code that we will do that to filter out only those 3 columns. Those are the columns that we are left with. Now, let's turn the data frame sideways or into a matrix. Okay, to do that, we use the unstack function, and we subsequently display the head. It has been turned into a matrix. So wherever there is no quantity, pandas puts NaN. So the algorithm uses 0 in that case. So we want to replace all NaN with 0. So to do that, we fill Na values with 0 by using this command, and you subsequently replace the contents of the data frame and save it again in the same data frame. So I'm just going to execute the code. As you can see, previously there were NaNs, now values. Now we have zeros and it, right? So the bulk of the cells in the data frame are the summation of quantities associated with the particular invoice. So in case the quantity is greater than 0, the algorithm requires us to reset it to 0. So basically each cell is expected to be either a 0 or 1. Abanmugona, the data type, it's a double or decimal. We need it to be either a 0 or 1, and it should be binary. So to do that, we are introducing a function that we have named reduced to binary, so that it executes that if quantity is 1, then return 1. If it's 0, then return 0, right? Now we want to call the function and introduce it to a data frame. This is the function that we've created. There is a built-in function runs a map that receives a parameter in the form of this function that will return and make the necessary amendments to our data frame. All right. Where am I? There we go. As you can see, it's now zeros instead of the 0.0. The data type is now consistent. Now we want to generate association rules from our dataset using the a priori algorithm. So the first point of call, we are going to import the algorithm and association rule function from the ML extend library. To do that, this is the code that comes with importing the a priori algorithm and the association rules, and they are building modules for that. Okay, here we are generating frequent items, and it using the a priori algorithm, and it receives 3 parameters: the dataset, the minimum support, and the columns. If it's true, it will use the columns in our dataset. If it's false, it will use the indices. In a similar fashion, it's the same code that will create item sets that receive the same parameters. Here, we want to generate association rules from the frequent item sets. To do that, we've introduced a new variable by the name rules, which is going to store the outcome from this function known as the association rules, and it's a built-in function from a priori that takes following parameters: frequent items, metrics that we are going to use, the lift, and the minimum threshold. Okay, so let me just execute this. It will display accordingly. So it is generated associations. Antecedents, as I introduced is the first item the user, a customer picks. But in this respect, these are invoices. Our data set rename invoices ese, so postage is not a product, and it so it's a shipping cost. So we have to clean our data to vise pese pane postage and tisarine product. So to do that, we are going to drop values where there is postage, and we're going to drop all the products with the postage as a description. We've just done that. Now we want to rerun the same code to generate association rules and see the outcome. We've just rerun the code. Now we have our products to say this is the first association rule, and it in a zero, to say that if a customer buys plasters in tin wood animals, these are gifts, and they are likely also to buy this. If a customer buys this product, they are also likely to buy this product. So we have generated association rules, right? And the insights that we get from the first rule is customers who buy plasters in tin wood are likely to also buy plasters in tin circus parade, is alluded by this outcome. For the second rule, rule number 1, customers who buy plasters in tin are likely, tin circus parade are also likely to buy plasters in tin wood animals, is alluded here. So this is how you generate association rule. And now that we have generated this association rule, we have specifically chosen a minimum support of 0.05, and minimum support of 0.05 here, to say that only look at items that occur at least 5% of the time in the dataset. So you can case or cast our net wider and capture rare items should we want to. However, we are now more interested in the lift, and so we want to sort by the lift. And if we do that, let me run the code. We get the following rules that have been generated, and from the rules, it shows that for rule number 1, those that buy plasters in tin are likely also to purchase that. So from those insights, we can bundle plasters in tin wood animals, this product, and this product. Place round snake boxes, set of wood, this is a product again. And also this product. And we can also target customers who bought that particular product around the Spacey Boy lunchbox with promotions for round snake boxes set for woodland. Okay, so this is how you generate association rules using the a priori algorithm. So key takeaways is, first, you have to import the dataset and also do feature selection. That is to establish the variables that you want to work with. And also you have to drop now values. It's part of data cleaning to ensure that you have data that is consistent, that has got no blank values. Is there a question before we conclude? Any reactions, Dr. Digito?
Thank you, Engineer. I think we can end our session.